2 point charges plus 9 microcoulomb and Q2 is minus 1 microcoulomb are held 10 centimeter apart. So our Q1 is how much? 9 microcoulomb. Let's keep it here. Let's make a diagram over here. So this is our A, this is our B. This is our plus 9 microcoulombs and this is minus 1 microcoulombs. They are separated by a distance of 10 centimeter apart. So let me draw here in between. This is our 10 centimeter, or let me just keep it as 10 into 10 to the power minus 2 to avoid mistakes. Okay. Where should a third charge plus Q be placed from Q2? From Q2. Q2 means the second charge from Q2 on the line joining them, so that capital Q does not experience any force. So we are placing a third charge, okay, along the line joining these two set of charges, but near B. Be very careful, we are placing it near B. Okay. So what we can do, let me repeat the whole question. Let's understand the problem in a simple way. You are given with two charges, 9 microcoulomb minus 1 microcoulomb. Both are separated by a distance of 10 centimeter. You have to place a third charge, capital Q, okay, on the line joining the two charges, such that the net force on this Q will be 0. Equilibrium, net force is 0, right? Okay. Let's see now the situation. Now, they said you have to place it close to B. So you have two options, either on the left hand side of B or on the right hand side of B, correct? These are the two only options. So basically, let's see what happens if I take it on the left hand side. So if you find the directions due to this plus 9, the force, okay, if you find, okay, that will be attractive or repulsive, that will be, this will be at this point, okay, it will be going towards it. And even the negative charge, okay, that is very, very small. So it is going towards the positive charge. So this is not a good idea, because the field will not cancel out here. The field will add up. Let me repeat again. If you take here the electric field direction for positive also outward, negative also inward. So add up. While the field will cancel out on the right hand side of B, because the field due to positive will be outward and due to the negative it will be inward. So there is an angle of 180 degree. So the good choice will be placing it on the right hand side of B. So let's take this, assume this as X, this point P as X distance away from charge B on the right hand side of B. Great. Net force is 0. Now let's figure out the force. Okay. Okay. So let's place it here. Our Q, a new charge. So what is the force on Q due to the first charge? So that will be F1. That will be equals to K 1 by 4 pi epsilon naught, which is K. Q is how much? 9 microcoulomb. So 9 into 10 to the power minus 6 into capital Q upon what's the separation? Sir, from A to B it is 10 centimeter. Then B to P, X. So total distance will be 10 plus X, okay, centimeter. So let me write here, keep a bracket and let me just make it 10 to the power minus 2 whole square. Let me repeat again, 10 centimeter. 10 centimeter means 10 into 10 to the power minus 2, and I assumed that it is also in X centimeter only, right? So 10 plus X into 10 to the power minus 2, 10 to the power minus 2, because both are in centimeters. Force F1. Let's figure out the force F2. So F2, force on charge Q due to charge at B, that will be again 1 by 4 pi epsilon naught. And this will be what? Our directions will be opposite. We know that. Okay. So this will be again how much? 1. So it will be Q into 1 into 10 to the power minus 6 whole divided by separation X into 10 to the power minus 2 whole square. Correct? I hope this is clear. These are the two. We have not taken the negative sign. Be very careful. Okay. We will take it. We will consider here the net force is 0, which means they are cancelling out. So F1 minus F2 is equals to 0 as per the question. The forces will become 0 only if they are acting upon in the opposite direction, right? So F1 will be equals to F2. Now what is our F1? F1 is 1 by 4 pi epsilon naught into Q into 9 into 10 to the power minus 6 whole divided by, this will be, let's make it as 10 plus X whole square, and that 10 to the power minus 2, this one, okay, what we will do? We will take it out of the bracket and make it as 10 to the power minus 4. because we have to cancel it, okay, and that will be equals to F2. What is F2? 1 by 4 pi epsilon naught. Q will remain Q and the charge will be 1 into 10 to the power minus 6 whole divided by how much? This will be x into 10 to the power minus 2 whole square. So x into 10 to the power minus 2 whole square, what I am doing? I am taking it out again into 10 to the power minus 4. Let's cancel out the terms, okay, the like terms or alike terms. Q is cancelling on both the sides. 10 to the power minus 6 cancels both sides, 10 to the power minus 4 cancels both sides, 1 by 4 pi epsilon naught cancel out both the sides. Let's take it, okay, this bracket on the right hand side. So 9 is equals to 10 plus x whole square upon x square. So this will give us, taking the square root both the sides, clear. So this will give us 3 is equals to 10 plus x upon x. So 3x is equals to 10 plus x. So x is equals to 2x is equals to 10 or x is equals to 5 centimeter. Be very careful. We took it in terms of centimeter. So let me check if there is any option. Yes, option C is the correct answer.